this time for what I'm going to try to do with DuckDB is use a little bit of more of the analytics features and some of the geospatial features of DuckDB. And what I have here is a set of data about a bunch of cities across the world. And I'll try to ask myself is what's the hottest city in Hokkaido right now using this data set? And the data set is I have about something of under 25,000 cities information downloaded, and it's about like 600 megs. So it's not a huge data set, but it's I'd say a small medium data sets to have. For each of these cities, I have a bunch of information in terms of, hey, what's the currency they use in that city? Do they drive on the left side or right hand side? And there is some geographical information as well, and there are some weather information, but of course not the current live information. This is the data set that I'll be looking at. And I will just give myself a little bit more space, and then I'll go over, well, how would I read the data from all of those cities? And I would start with, well, hey, like, how do I just look at those files? And again, hey, I just have a read statement. I'll just go over all of those JSON files. It's a relative path, and then start reading it. I'll notice I have, when I'm reading it, I have ignore is equals to true. Not every single file has every single piece of information, so it ends up being some errors if I try to parse everything out. But and then for the fields that I have, I verified every single field that I'm trying to go is actually in every single file. So let's just try to look at the statements there, the values that are here. There's a bunch of information about just the API itself that I'm using. It's from OpenCage. But what I'll do is just take a look at not everything, but just look at some of the geometry information. Okay, so I do have latitude and longitudes. And this is a bit of a long query, but what I'm looking at is, hey, amongst all the information that I have country information, I have state information. I'm interested in cities in Hokkaido. So I do have the cities in Hokkaido's in a format that I kind of want. And here's that's the kind of very nice features of DuckDB is, hey, I have 600 megs of files, over 25,000 K of files, but it parsed it within half a second, and it gave me all of the 33 cities in Hokkaido that are part of my data set and a longitude and latitude. Now what I could do is something very simple where I can go over each of the cities, loop at them one by one, and grab the current temperature, and that would find me the hottest temperature. But what I want to do is try to see, can I look at a subset of this data, but still come up with a very close and approximate answers for this. So the first thing I want to do is I'll store this data in the table because I already want to use it. And then so I have a table called cities. These are the cities that I'm interested in. Okay, and now, so now the way that I'll go over this approximation is I'll use this H3 geospatial library, which is how do I take a piece of the world, the entire world, and cover it with hexagons. I'll just have a quick visualization of this is, hey, I have the world of the map, and here is a covering of hexagon over this entire map. So this is a nice special way of dividing areas. If I look at Hokkaido here, and it's covered by 3 hexagons. If I zoom in a little bit and change the resolution of my zoom in, I can see that Hokkaido is covered by 9, 1, 2, 3, 4, 5 hexagon. And so, so if I can get the hottest city in each of those 5 regions or 3 regions, I'll get a pretty good idea of which is the hottest city in Hokkaido. So let's just look at how it's going to work. So I'll just load in this extension, and I'll do something. For example, if I have a longitude and latitude, can I get the information about the cell? So each of those cells here are identified by a unique number. And yes, I can, using this geographical information, I can find a cell that gives it to me. And the cell depends on this resolutions. There are kind of a hierarchy of these hexagons, but I can find one of the hexagon with this resolution that contains this point. And at that resolution, there's only a unique one of them. So now what I can do is, well, for all of my cities, grab this information along with the metadata that I've already gathered, and I'll have a bunch of these hexagons. And now that's the nice piece of this is I can go over and then just group by those cells. I don't want to have every single city, so I just want to have a representative city for each cells and be able to take a look at that. And the way that I'll do it, I'll group by cells, and I'll just grab any of the cities. That could be maybe the first cities or the last city, but in this case, there's no real way of differentiating between them. I'll just grab a city representing it. And I can do the same thing with, maybe if I had, if I remember the resolution of 1, I would have 3 division of Hokkaido. If I do a resolution of 2, I'll have 5 cells. And then I can see that, hey, I have 5 cities here. So this data set does have a spread now nicely around that I have representative cities for each of my cells. So now what I would like to do is add a few more commands of maybe another field, which is, hey, give me the current temperature at that city. There is no functions like this within DuckDB. So what I'll do instead is go over to Python and use the DuckDB binding within Python to obtain the same thing. So what I'll do is just go back to Python and I'll call in DuckDB request module, because I'll may have to make a call to some API that gives me the current weather, and then just again load that same extension. And I'll just re-grab the same query that I've done, the kind of the same cities here. So now I have a table called cities, and then I can see from Python, I can make the same call where, hey, I can just run the SQL query that gives me the city information at the resolution. Now, what I really want to use for Python is the ability to make REST API calls, but it's also to build new methods within DuckDB that are based on Python methods. So first, what I want to do is define a Python method, which is goes to open weather, and based on our latitude and longitude, give me the current temperature. Well, give me the current weather information about this. And so that gives me, well, so first to just deal with open weather, I do have an API key. I'll just read my API key and then define that method. So now I have a method which just makes the weather call. So if I just use those same longitude and latitude and make a call using this method, I get the current weather. Is it raining? What's the temperature? What's the humidity? And now the real nice thing is using DuckDB is I'll do a create function call, which is I'll create a new function for DuckDB based on this this Python method. So I'll just give it what's the name that I want to use within DuckDB? I'll just use the same name. What's the name of my Python function? And what are the arguments? Well, it's the longitude and latitude, which is 2 doubles. What I'll return? Well, I'll return this piece of text. I'll just return a varchar. And now I'm ready to make that call within DuckDB, where I will go. I have again, the same thing where I call a city. I call the cell method. So this is the geospatial information coming from DuckDB that already exists. And from there, I have this new method that I'm calling from DuckDB, which is to give me the current temperature. And this is a new method that is now part of DuckDB. And from there, then I'll have from my list of cities, and I'll group them by those cells and give me the return temperature. So let me just go ahead and create that function here and return the method. And I can see, I found a city which has its 10.99 degrees Celsius in Akibira right now. And that's kind of based on this resolutions of 1. But if I would zoom in a little bit more, I could give those 5 samples. And now I have 5 samples. I actually found a city that's a little bit hotter of that. I'm not saying I'm going to get the correct answer. I'm going to get an approximate answer. But if I zoom in one more, maybe I won't find anything more. I still found I could zoom in more, still looking only at a subset, like a third of the cities that I was have, and then look at all their temperatures. Again, I'm improving my approximation, but the cost will take longer to make those calls. And that's all I have for today.